So we have to talk about now the average rate of change. The average rate of change is something that'll come up in later courses, um, but we've seen it already. This is where if you have a function from a to b, you do f of b minus f of a over b minus a. Technically, this is slope. It tells you the average speed over a certain amount of time. But not all equations are going to be linear, so it's not going to be this. But the average rate of change for this is going to be over a particular function between two values. So here is a function I'm going to give you. F of x is x squared minus 5. I'm going to let a be -7, and I'm going to let b be 2. Okay, so for this, first thing I want to do is I just want to fill in everything. So this is going to be f of 2 minus f of -7 over 2 minus -7. So probably a good idea would be to go ahead and find what f of 2 is. We've talked a little bit about that, or you've seen a little bit of that already. So if we just took f of 2, this is my function. I'm plugging 2 into my x value here. So this will be 2 squared minus 5. So that is 4 minus 5, which is -1. And if I go ahead and find f of -7, this will be -7 squared minus 5. Now we can do this in our head or use your calculator. But if you use your calculator for -7 squared, make sure to use parentheses because this is positive 49. We all know that, but I can't tell you how many times people will write down -49. Don't trust your calculator that much if that's you, okay? But we should get 44. So what I have here then, let me change back to black, is I'm going to have f of 2, so I'm going to put in -1, and now I have subtraction, and I have f of -7, so that's going to be 44. Now 2 minus a -7 means 2 plus 7, so that's going to be 9. So my average rate of change between these 2 points over this graph is going to be -45 over 9 or -5. So basically this is our answer. That's what we're looking for. The other thing in this section is the difference quotient, or the other thing in this homework set is the difference quotient. Most times students have seen it. You may not have worked a lot with it. You'll see this in another course too called, both of these will be in calculus. I know that, so if you're taking elementary calculus, which would be kind of like business calculus, Math 130 here at Midlands, or if you are, it's also for social sciences, those majors as well. In our case, I'm going to let f of x be, let's do just 5x squared. So this, one of the first things I want to do is find f of x plus h, which would be 5 times x plus h squared. So if I square this, just keep in mind what we're really looking at, and this is x plus h times x plus h. So this is really 5 times, I have x squared, I've got an xh and another xh, so that's plus 2 xh's, plus finally my h squared. So this is 5x squared plus 10xh plus 5h squared. So if I put this into my difference quotient, look how long that f of x plus h is. We're going to put in 5x squared plus 10xh, excuse me, plus 5h squared. And now I'm going to subtract. I'm going to put in my f of x. And it's all over h. So one thing that you'll start seeing with these difference quotients is that everything without the h is going to cancel. That's good. So you'll have 10xh plus 5h squared all over h. Now, this h is going to go under both terms. It happens like this. There's an x, sorry. 10xh over h plus 5h squared over h. So our answer is 10x plus 5h. The other way that you could do it would be just to take out an h. This is called factoring. We're going to factor out the h. And then at this point, we can knock it out. So this is going to be 10x plus 5h. So either way it works. I'm going to do another one of the difference quotient. I think it's a bit harder. So I'm going to have its own video for that.